Today we are going to be solving problem 3.2 in Math Methods by Riley. By considering the real and imaginary parts of the product e to the I theta times e to the I phi, prove the standard formula for cosine of theta plus phi and sine of theta plus phi. We'll start by writing the product as e to the I theta plus phi, because when two quantities with the same base are being multiplied together, then you can add their exponents, and that's exactly what we did. Now we can use Euler's formula to write cosine theta plus phi plus I sine of theta plus phi. And then I'm also going to write, using Euler's formula, e to the I theta as cosine theta plus I sine theta, and then e to the I phi as cosine phi plus I sine phi. Now, using equation 1, we are going to take the real part of e to the I theta times e to the I phi, which is cosine theta plus phi. Then using equations 2 and 3, we're going to multiply them together and then FOIL. Foiling, we get cosine theta times cosine phi plus I sine of phi times cosine of theta plus I sine of theta cosine of phi, and then I times I is -1, so we're going to have a minus sine theta times sine phi. Now, if we take the real part of this equation that we just made, let's call it 4. We take the real part, then we get cosine of theta times cosine of phi minus sine of theta sine of phi, because those terms do not have an imaginary number attached to them being multiplied. Now, if we look at this equation and this equation, the left-hand side is the same. Therefore, these two quantities must be equal. And that's exactly what we're looking for. So cosine of theta plus phi is equal to cosine of theta cosine of phi minus sine of theta sine of phi. And this is the normal formula for cosine of theta plus phi. Or some places have it written as cosine of A plus B in textbooks or online. Now we can follow a very similar procedure to find sine of theta plus phi, but we'll just take the imaginary part instead of the real part. So taking the imaginary part of e to the I theta, e to the I phi, yields sine of theta plus phi. And then once again using equation 4, this was using 1. Yep. Now we see that these two terms are imaginary. So we have sine of phi cosine of theta plus sine of theta cosine of phi. And then we just need to set these two terms equal to each other, and we have the standard formula. And that's it.